So the first part of most statistics classes is a study of counting arguments and probability. And so in Algebra 2, we kind of give you an introduction to those concepts. It's a pretty good introduction in terms of just the basics. So this is the mathematics of how to count the number of possibilities in which something can happen. So for instance, there are two kinds of counting thoughts. One of them is called a permutation. A permutation is when you arrange anything where order matters. For instance, if I have the word pass, that is not the same when you spell as the word saps. So that's a perfect example of the order of this word matters. Another example of that is a password or a combination, which is kind of funny. If you've ever used a combination like on a locker or a combination lock, it actually probably should be called a permutation lock because you can't just put those numbers any way you want. Like if your combination is 12, 18, 6, you can't put them in as 6, 18, 12. The lock won't open. Okay? It's kind of funny because we call that a combination lock. Well, a combination lock is arranging anything in random order. An example of that is a bacon, lettuce, and tomato sandwich. Would be the same thing if I put that as lettuce, tomato, bacon. Now, some people might say it matters to me on my sandwich. Let's say this is a salad. Let's say you had a salad that contained bacon, lettuce, and tomato, and then someone served a salad next to you in which it was lettuce, tomato, and bacon. That would be the exact same salad. So again, arranging anything in random order, but having the same items, that's combination. If the order matters, that's called permutation. Now, both of these concepts can be grouped or not grouped. So we're going to look first at grouped, not grouped items, meaning items that are just by themselves. So if those items are in a row, we're going to have a new mathematical symbol. It's an exclamation point. It means factorial. So an example of that is if you have three books and you're going to stack them. And say you have history and you have science and you have math. Well, the order in which those can be arranged, it doesn't matter. You're just stacking them, right? It doesn't matter. I didn't say alphabetize. I just said make a stack. So when you do that, you could actually do this in 6 different ways. You could do HSM, you could do MSH, you could do HMS, and so on. And the way you would understand that is the first time you place a letter, right, you would have 3 ways to do it. So as soon as I pick one of these, let's say I pick S, the next time I pick a letter, well, I've picked this one, so I would only have 1 way to do the next one. Sorry, 2 ways to do the next one, because I can pick between H and M. And then the last one, this is done, so you only have 1 way. So to pick that last letter, you have H. And if you did that again and picked a different letter, you would still have the same combination of 3, 2, and 1. And that's called factorial. Factorial is when you take the number of items and you multiply each possible combination until you get down to the last one. So in this example, this would be called 3 factorial. Okay, and that's a very important concept for probability. So if you have circular or connected events, let's say you're seated around a circular table and you have 3 people. Let's say you have Mr. King and Mr. Shepard and Mr. Meermans around the table. Then what happens is that these 3 people, they're actually connected. So one of the possible combinations is subtracted. So if you ever have circular or connected items, these 3 books, if I put them around the table, would have the same idea. It would just be subtract 1 of the connection. So it would be 2 factorial in this case. Okay, you could also have duplicates. Now, the idea of a duplicate here is what if I was arranging these books and I had history, science, math, and then I had an identical math book. Well, you would actually divide out those duplicates. So what you would do here is you would do 4 factorial because there are 4 items. Okay, but then you would divide out the fact that you have 2 identical math books, and that will actually reduce to 3 factorial. So it's interesting. It'll reduce the same value as 3 factorial or 6. So that's interesting how that works, and there can be more than 1 duplicate. So in that example that I showed you there, you could have a duplicate. You could have like 3 science books, And so then you would do 1, 2, 3, 4, 5, 6 factorial divided by the fact that you have 2 math books and 3 science books. Okay, and there could be more than that. I mean, there could be a third duplicate. I could have 2 history books as well or something. So the next thing is what happens if you have a list of repetitive values. And that's an example of that. A perfect example of that is if you are trying to figure out how many possible combinations there are in, let's say, a lottery, right? You know, when they pulled those balls out of that like magical blowing fish tank of things, if you've ever seen that on TV, then every time, you know, they move from one tank to the next. And so let's say there's 50 balls in the first thing. There's 50 possible ways to get whatever number you chose. And then they go to the next tank, and there are 50 more. And they go to the next tank, there are 50 more. And they go to the next tank, there are 50 more. They go to the next tank, there are 50 more. So mathematically speaking, this would just be 50 to the 5th power, which is, by the way, an enormous number, and that's why it's hard to win the lottery. Okay, we can also group items, okay? And this is when the word permutation and combination really come into practice, though some of these may be permutations or combinations as well. This is where you really have to pay attention to what you're looking at. So the N is the total number of items that you have possible to choose from. P stands for you're choosing permutation, and R is the group you selected from that total. So a permutation or purposely arranged group in where order does in fact matter. An example of this is running a race, winning an election, a science fair. Again, password does not equal the same thing as drowsap, right? They're not the same, okay? So choosing a password is another example of picking letters out of the English language or whatever language you use, including numbers. And that is a selected group of in order values. Okay, there is a formula for that, and this is given on most formula sheets, including the SOL in Virginia. We don't actually use this. We will use either a calculator or use Desmos. That being said, another way of thinking about this is it's just limited in factorial. And we'll talk more about that when we have an example. But if you have, for instance, if I come up here and I have, these books, but instead I say you can only stack 2 of them, again, you're choosing 2 books and limiting it. Now, if the order matters, it's a permutation. If the order is random, that is a combination. So, good introduction to this topic. Same thing, N is the total number of items you're selecting from. R is a selected group from that. C means you picked combinations because it's random. An example of that, especially on the SOL, are keywords like the word committee, jury, panel, or if you happen to be dealing cards, you obviously cannot do that purposely or you're cheating. So another example, again, example of what I'm talking about, a perfect example here is ordering a pizza. If you order a sausage, onion, pepperoni pizza, and it comes out pepperoni, sausage, and onion, you cannot tell the difference. It's the exact same pizza. And so the formula is almost the same. Look, we have an N factorial, we have N minus R factorial. Remember, R means the selected group. But then you're dividing out R factorial, which is in fact dividing out your duplicates. It's actually an application of this duplicate formula to the permutation formula. And so you can think of that as limited N divided by repeated events, which is a really good way to think about it.